Hi guys, welcome to Graphing Polynomials, and this is part one of this, and we're just going to focus on the factored form. So before we get into that, I just want to talk about some patterns and some things, just some general things that you'll see. So what I did is I just sketched a graph of each of these equations, and so I just want to kind of make some generalizations. So the first thing is notice that these are like x to the first power, and they create a line. So these are linear functions. The next two, they create parabolas. So notice they look, they have the same look. So these are quadratic equations. The next one, the next two actually, they have the same look, and because they both have x to the third power, they're called cubic functions or equations. And then finally, notice the look of these two are a little similar, and these are called quartic functions. And it's because of the 4. So if you'll notice the exponents, they determine the name of the polynomial. Now, after 4, we get down to like 5 and 6 and on and on and on. We just call them polynomials, so they don't have a special name. But x to the first is linear, x to the second is quadratic, x to the third is cubic, and x to the fourth is quartic. Something else that I want to talk about the exponents is if you have an even exponent, you have an even function. If you have an odd exponent, you have an odd function. So I'm going to look at this, and the type is going to be an odd function. Same thing with this one. But these, because they're 2's, these are going to be an even function. The 3's are going to be an odd function. The 4's are going to be an even function. The 5, so that's going to be odd. The 6 is going to be even. And the 15, that is going to make it an odd function. Okay, so the next thing I want to talk about is the end behavior. So I want you to think about, okay, does it go low, low, high, high, low, high, high, low? And so we're going to call that like negative infinity, positive infinity. And so we're dealing with just the end. So like, for instance, this is going to go down in negative infinity, and it's going to end in positive infinity. So again, I'm going from left to right. This one is going to start in positive infinity, or just infinity, and it's going to go down to negative infinity. This one is going to be high, high. So this one is just going to be positive infinity or infinity and infinity. This one's low, low. Do you see that? Low, low. So it begins low and it ends low. What about this one? So this one is going to go negative infinity and then positive infinity. This one starts high, ends high. So positive infinity, positive infinity. This one starts low, ends low. And so we're going to see kind of a connection. We're going to make a connection between the type of function and the type of graph and its end behavior. So let's start at all the even functions. So we have an even function right here, an even function right here. Let's go down and find another one. Oh, we have an even function right here. We have an even function right here. Okay, so how did those compare to the other ones as far as end behaviors? So take a look at what you've written. How do they compare to the other ones? Well, if you'll notice, the even functions, they're either both high, positive infinity, or both low. So let's look at another one. So this one is both positive, positive, and this one is both negative, negative. So they have the same end behaviors. So So if you'll notice this chart here, we're looking at the even functions right now. So right here. So if you'll remember, a leading coefficient, that is the number in front of the exponent that determines the degree. So like for instance, we have like negative x squared or positive x squared. So I want you to kind of make a connection where one of them is going to be positive, positive, and one of them is going to be negative, negative. So go ahead and look up at our functions. So it doesn't matter if it's a 2 or the 4. We'll look at this one. And actually, let's look at this one. So notice that if it's a positive leading coefficient, a 1, it's going to be positive, positive. But if it's negative, it's going to be negative, negative. So let's go down here. So even degree, positive leading coefficient, that's going to be positive infinity, and negative leading coefficient is going to be negative infinity, negative infinity. And guys, I want to notice there's a typo here. This should be negative x to the 4th plus 1. So it's graphed correctly. It was just written incorrectly. So I wanted to point that out. Okay, so let's go to the odd functions. So notice that they have opposite signs. They go from negative to positive, and this one goes from positive to negative. So let's look at the coefficients. So if it's positive, it's going to go from negative to positive. But if it's negative, it's going to go from positive to negative. So the way I think about this is that it's opposite. If you have opposite, odds are opposite, and so you're going to start opposite. So positive is going to start out negative and go to positive. Negative is going to start out positive and go to negative. Okay, so we're going to talk about the number of times a 0 appears. So this has to do with the number of your exponent as well. So like x to the 15th power has 15 zeros. X to the 6th power has 6 zeros, and so forth and so on. So x to the 1st power has 1 0. X to the 2nd power has 2 zeros, and so forth and so on. Okay, so if it's x to the 1st power, we've talked about this. This is going to be straight. It's going to be a line. Everything else is squiggly to a certain extent. So like x squared is always going to have a bounce. It's going to be a parabola. But anything more than that, there's some kind of squiggle. So it can look like that, or it can look like that. So it has some kind of squiggle or a snake or whatever you want to call it. So that's something else to learn about the exponents. Okay, so now that we've learned all that, we are going to graph it and talk about the graph. So the first thing I want to point out is that this is a negative, and my degree is going to be 3 because I have a 2 here and I have a 1 here. So we haven't really talked about that yet. So my degree is going to be 3. My leading coefficient, because it's a negative, it's not a number, so we're going to call that -1. So if I have an odd degree and a leading coefficient as negative, so it is right here. We're going to do that one. So our end behavior is going to be positive infinity to negative infinity. So this is an intercept form, so I can find the intercepts really quickly. So that this intercept is -1, and this intercept is 3. So let's write that down. So -1, 0, and 3, 0. And then to find the y-intercept, we're going to set x equal to 0 and solve for y. So let's see. Y equals -0 plus 1 squared, and then 0 minus 3. So 0 plus 1 squared is 1. So I have -1 right there, -1 times -3. So y equals 3. So it crosses the y-axis at 0, 3. Okay, so we're going to use this as our guide to kind of help us. So I know that it starts up here, it starts in positive infinity, just like it told us to do, and it goes through the Y-intercept, and then it's going to bounce again, and it's going to go down in negative infinity. So this isn't perfect, but it gives us an idea of like what is happening at certain points. So this is totally great. One other thing I want to point out is that because this is part of a squared, that tells me that it's a bounce. So it bounced off at -1, so that's what's giving it that. Okay, so let's go to the next one. So I have a polynomial of degree 3, because 1, 2, 3. Let's talk about my x-intercepts. I have an x-intercept at 4, an x-intercept at -3, and an x-intercept at 1. So 4, 0, -3, 0, 1, 0. So let's go ahead and graph those. 4, 0, 1, 2, 3, 4, -3, 0, and 1, 0. Okay, the leading coefficient is right here. It's 2, and it's positive, right? So we have odd degree, positive leading coefficient. So let's go up here. So odd degree, positive leading coefficient, we're going to go from down to up. So negative infinity to positive infinity. Okay, and then the last thing is a y-intercept. So I'm just going to set x equal to 0. So I have -4 times 3 times -1. And I get my y-intercept is 24. So it is 0, 24. So this is way big. So I'm going to just mark that up here. Okay, so let's put this together. Notice I have no bounces because there's no squares. So it's going to go from negative infinity and then go to positive. We're going to end up in positive infinity. So I have this curve going up here to 24, then it's going down, and then it's going back up. So what I was saying before is I don't know how far down this goes. I don't know, but that's okay. I'm giving the basic look of what the graph looks like. Okay, so the first thing I notice about this is it's a polynomial of degree 4. It has a leading coefficient of 1/2. It has 2 bounces here, so I'm thinking about that. Okay, so because this is positive, the end behavior is going to be positive infinity, positive infinity. So it's going to start up and end up. My x-intercepts, I have one at -6 and one at 2. So I have an x-intercept at -6, 0 and at 2, 0. Okay, so my y-intercept is going to be, I'm going to set x equal to 0. So y, let's see, 36 divided by 2 times 4 is 72. So my y-intercept is at 0, 72. So it's way, 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 way up here. Okay, so go ahead and graph it and see what you get. Okay, so it should look something like this. So there's that y-intercept at 0, 72. And here are my other 2 bounces. And we are done.